I am Pradeep Ganesan. I'm based out of Victoria, Canada. It's located in Vancouver Island, the western part of Canada. This is the warmest part of Canada. A fun fact. I have been a software developer my entire career, and recently I've been freelancing in software development. I've spent all my time in data storage, recently on cloud storage, file systems, distributed systems. So today we are going to learn about how to debug a C program using GDB. GDB is the abbreviation for GNU Project Debugger. Usually, or the easiest approach that developers usually take for quick debugging is to add in print statements or log statements and run a program and collect all those uh, statements that are printed out and then trace through the program, how it was executed, what was the flow in it, and if there was any unexpected behavior they hope to catch in those statements. It's a pretty good approach. It's a fairly simple, the easiest to go with, and it has helped me a lot, that approach. But it doesn't always help, especially when you face segmentation faults, due to memory leaks or any other memory errors, or um, if there's a loop that runs for like thousands of times, going through those statements might be difficult. Although you can use tools like grep to grep out what you're looking for, and it helps you with debugging quite well with the print statements as well. GDB is a more advanced um, way to how to debug a program, but the main advantage of using GDB is that it gives you that facility to debug a program on runtime. So when you execute a program, it it provides a way for you to pause the execution at runtime at any point where you want, and then look for the state of the program at that point where you paused it, and then continue the execution again. Stop anywhere you want, or pause. I wouldn't say stop. I would say pause. Again, look for what's the current state of the program and then continue. And you can do this um, as many times as you want. And there are lots of commands that help you with this. So when I say pause, it's called as a breakpoint in debugger, in the GDB debugger. So you can set breakpoints at different statements or lines in a program, or at a function name in a program, and then when you start the program with the GDB, it's going to go and break at that line. When I say break, it goes and stops at that line. Stop really gives, I mean, it might mislead you, so that's why I use the term pause. So it pauses the execution at that line wherever you set the breakpoint, and then you can print out what's the current values of the local variables or the global variables or the arguments that were passed to the current function. You are in the context of that execution of that program. So today we'll do a simple demo on how to debug a C program. I could have come up with a presentation on different commands, but it only takes you to a certain level. We can try to remember those commands, but it really wouldn't help until we go and try that out. That's always been the case with programming. We need to be hands-on to remember how to do things. So I thought this would be enough talking about GDB. Let's actually go and show how it works. So that way it's easier for the for the listeners to understand how it works and how to use it. So as an example, I'm going to write a simple program, which is to given a string, reverse it. I practiced this program before recording this video, but here I'm just going to try and write it again live. Let's see how that goes. I'm going to take a simple approach, not any fancy items, like I'm not going to get the value or a string from user from command line or anything like that. I'm just going to have a hard coded string value. Let's say you have a city name. This is my habit of always going with a null pointer and then allocating it. I could have just given a constant string here, but I'm going to go and allocate it. Let's say I give it a size of 256 characters. And always a good habit to check if the allocation is passed or not. If not, throw an error. Maybe I can try this. All right. So now let's assign a value to it. I love the city Vancouver, city of Vancouver, British Columbia. Let's do that. Use that. All right. So I'm gonna print the string, then I'll reverse the string, and then print the reverse string again and exit the program. So to reverse the string, I'm gonna write a function. And pass the string to that function. Let's have a generic argument name. I'm not gonna go explain how to reverse a string here. I'm gonna assume that you understand the program, but deliberately I'm going to induce a bug in this function, which will lead to a segmentation fault when I run the program. I'm quite sure most of my listeners, or all my listeners, would be able to spot the bug right away as I type it in. But please hang on. I'm going to fix that using debugger. I'm going to make you understand how to use debugger to find that bug and then fix it. So that's the goal of this tutorial. All right. So I'm going to a typical solution for this zero string, just one line or a few seconds. I'm going to explain it. Go from both ends of the string um, and keep swapping the characters. I'm gonna have a head index. I'm going to have a tail index that would be the length of the string minus 1 because it's a zero indexed character array. Now let's go ahead and reverse the string. Going to hold that in a temp. storing the the head character and swap. Yeah, I know what you're thinking. Please hang on there. I will come back to it. Okay, now let's go down to main. Let's call this function, hoping that it would reverse the string or the city name and print it again. We should be returning success. On the right side, on the right pane, I have the terminal. So I'm going to, oh, all right, yeah. Going to show you how to build it. I'm building it with, compiling it with GCC, and the option -G, it's going to compile it with debug symbols, so which GDB uses to debug a program. And then give the C file. I'm going to specify uh, binary name. Oopsie! I got to include string.header file. Yeah, there you go. All right. So we have program compiled without warnings and errors. Now let's run it. Oh, so I have got a segmentation fault. All right, so there is been a memory error. What could be the reason? Let's use GDB. Clear this up. How you use GDB is to pass the binary to GDB program, and first it loads the symbols from the binary for all required for the GDB to keep states of the program during execution. So I'm going to provide the binary name. As you can see, it says reading symbols from that binary. And now there are two ways to start the execution. At this point, it hasn't started executing the program yet. You can either use run or start. Run is going to just run the program from start to end. But if you give start, it's going to automatically create a breakpoint at the main function and stop there for you. Let's go with start and see what it does. There it goes. It says temporary breakpoint 1 at an address, which is the program pointer, which says the line number in the program. So what's line 23? It is the main function, start of the main function, as you can see on the left pane. So at this point, if it's at a breakpoint, what it means is that the program is actually in its runtime. It's currently been executed, but it has hit a breakpoint because of the automatic breakpoint that GDB adds on the main function when we give the start command. And it's right now at that point. It has stopped at that breakpoint. It has paused at that breakpoint. Here I can, if I want to print out what the current values of the variables are, I can do that. So if there are ways to do it, there are three scopes of variables, global variables are the current function's arguments, and the local variables of the current function wherever the execution context is. So if I say info globals, there are no hmm, what? Oh, there are no global files. That's why, sorry, no global variables. Let's see. Oh, sorry about that. It's not info globals, it's info variables. Variables, what you see here. See, all global and variable names, static variable names. That's what we want. So variables. There you go. We don't have any global variables in our program. These are all from the compiler, which we don't have to worry about. Do we have any locals? Local variables? Yes, we do. There is a city name, and the city name at this point is still null, right? Do we have any arguments to the function? We are in main function, so yes, there is two arguments, argc and oh, I spelled it wrong. Argc and argv. Argc has taken some junk value at this point. Argv is null. 0x0, the hex value 0 represents null. Now let's, as you know, our program is now at line 23, right? Now let's add a breakpoint at our own, one of the lines that we want to. Let's say I want to add a breakpoint at 32. So I would say line 32, create a breakpoint there. Then I'm going to tell GDB to continue the execution. So what happens is it now stopped at breakpoint 2 because it executed lines 24 to 32 and stopped at 32 because we have put a breakpoint there. So now let's see what's the values of the locals. The city name is still empty because we have at this point we have allocated for the city name, but we still the line is stopped. The execution is stopped at 32, but 32 hasn't executed yet, right? So the city name has got a memory location allocated for it, which is filled with zeros. That's what calloc does. So that's why the string is shown as empty. Now I'm going to execute this line. So for that, there's a command in GDB called next. When you give next, it's going to execute the next line in the current function. There's another similar command called step. But what step does is it will step into the function in that if there is a function call in that line, in this case strdupe, it will step into that function and go line by line. But I don't want to go into strdupe, just want to execute this line. So I'm going to say next. So it executed that line 32 and went to the next line. So now if I say info locals, there you go, city name has Vancouver. I can print the city name using a print command as well. Print city name. And I can use this to even print a specific character. I can print the first character V, or I can print the fourth character, which is C, and so on. So now let's go and put a breakpoint at this while loop in reverse string and start debugging the program to find out why there was a segmentation fault. So I'm going to add a breakpoint at line 12. And then now I want the program to continue execution and go break at that line. So I'm just going to say continue. So it will execute all lines that lead up to that break line at the breakpoint. So I'll say continue, or you can simply even say C. And now we are at the while start of the while loop. Now we are in the function reverse str, this function. So we'll see what are the, when I say info locals, now it's going to print the local variables in that function. Now we are in the context of that function, right? The scope is in that function. So the locals would be the variables in that function's scope, which are head, tail, and temp. If I say info args, it's going to print the arguments of that function, which is the string itself, Vancouver, what we have passed. So now head is in 0, tail is at 8 because the length of the name Vancouver is 9, and because it's 0 index, it's the index is at 8. So now let's say continue. It's going to execute the program, the while loop once, and then come back to the while header, right? Or the other way is let's actually go line by line. So let's go to next line, which I can use just n instead of next. Now I'm at the first line in the while. It hasn't executed it. Let's execute it. Now if I say info locals, temp is going to take the character V, the first character. And now I'm going to go to the next line, next line, next line. Now head has incremented, tail hasn't incremented yet because it's at that incrementer statement. Let's go to the next line. When I say next line, it tail plus plus also gets executed. So now when I say info locals, head has been incremented, tail has been incremented, and temp is at V. So now I can see the bug. Tail is at 9. And you know what? This string itself is only 8, 9 characters, which means it should maximum be indexed at 0, 8. And we have to decrement tail. We shouldn't be incrementing it, right? So that's where the seg fault had occurred. It has run over the allocated memory. Because this while loop is going to run forever. It's going to go beyond, the tail is going to go beyond 256 characters what we have allocated, including head. And head will always be less than tail because both head and tail are incremented by 1. So the moment tail, which is the first one to hit 256, it's going to seg fault. That's why we got the seg fault. Even logic wise, this is wrong because we want the tail index to be decremented. So we want to keep swapping the first and the head character and the tail character, increment head, decrement tail, and then swap those characters and keep moving until head and tail hits each other or becomes the same, or head surpasses tail. So that was the bug. So we found it. We can even say I'm going to clear all the breakpoints, and I'm going to say continue. See, the seg fault had occurred. So when the seg fault had occurred during the execution in GDB world, we can print the trace, what's called as back trace, which will give you, it's with the bt command, it will give you the trace of the function calls that led up to this seg fault. So it has first, it's in the reverse order. The last line says main function at 35 is the function call. So it came to the it called this function, it executed that function, and in that function at line 14, which is here, is where the seg fault had occurred. Why? Because str tail, which when it was 256, is beyond our allocated memory region, and the seg fault had occurred. Boom, now we got it. All right, so let's go and fix it. Let me quit the GDB and fix our bug. Tail minus minus. Let us compile it again and then run the program. There you go. The string got reversed. And that is how you use GDB. This is a very simple demonstration of how to use GDB. There are a lot more commands that are available in GDB that you can use to um, debug a concurrent program where there are multiple threads, multi-threaded programs, um, and whatnot. There's no limit to it. It's an amazing tool from GNU that helps you with manipulating a program during execution time. GDB is a very valuable tool. Learn about it, read about it, use this as a. I hope this video is going to help you to get more interest in GDB, and good luck. Thanks again for listening to this demo, to this and watching this video. If you like it, please subscribe to my channel, and hopefully I get to see you guys again in my next video. Thank you. Take care.